all right, we got a box sliding across the floor and it stops. Everything's horizontal, so what that means is that the friction force is going to be mu mg, and there's work done by it to slow it down through a distance x. And the effect is that the kinetic energy gets wiped out. So the m's cancel, and I'm going to be able to say that mu equals v squared over 2g, and that's going to be 100 divided by 2. Oh, sorry, and then there's an x down here over 2gx times 10 times 25. So this ends up being, these cancel, so 10 over 50, which is 0.2 b. Now let's be clear. There's a force on the box to the left from the friction, and there's a reaction force on the floor to the right. So that's choice E. And then here, ooh, this is complicated. Let's draw the free body diagram. You should memorize this one. This is F, right? So we got a normal, we got the weight, we got friction, and then we've got F cos theta and F sine theta. So we get F sine theta plus the normal force minus W equals 0. So my normal force is going to be W minus F sine theta, which is mg minus F sine theta. And then horizontally speaking, we've got F cos theta minus the friction, which is mu mg minus F sine theta. And the effect of this force is 0 because we're moving at a constant speed in a straight line. So that means the acceleration is 0. So we're in a kind of equilibrium. So when we isolate mu, that's going to be F cos theta over mg minus F sine theta, which is choice E. All right, I'm going to actually do 2 pages in this video just to kind of keep it moving. So here's the deal. We get a rope and pulley system with negligible mass, and it's the same tension throughout the rope. So we've got tension, tension, tension. Oh, that's bad. Tension, 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 and tension. So what we notice is if the force is balanced, we get 4t equals the weight. So t is weight over 4. Now notice on the spring scale we've got 2 tensions, each pointing down. So what this tells us is that the reading on the scale is going to be 2t, which is going to be 2 times w over 4, which is w over 2, choice B. Awesome. This is a center of mass question, which I'm going to answer, but we're not going to see too much of this on the exam. So the center of gravity, the center of mass of this object is right there in the middle, and it's going to point straight down. Okay. So that's L over 2 right there. Okay. And basically, if this angle is 60 degrees, this distance here using special angles, right, should be L over 4 because that's the sine of 60. Or like, sorry, the cosine of 60. So that's L over 4. So what this tells us is the rule with the center of mass is when you remove this, the center of mass really shouldn't move at all. So what's going to end up happening is that this thing is going to drop straight down. And so we should have the end of the y thing slide out this way to give us a total distance of L over 2. And that means the total distance is L over 2, which means it had to slide 1/4 L to the right. All right, and then 26. In an experiment, an object is released from rest from the top of a building at speed v is measured as it reaches a point that is a distance d from the point of release. All right, so first let's just do a little math here. So d is, so v squared equals 2 times g times the height. So v squared over 2, let's get v isolated. So v is going to be square root of 2gd. Now let's double this distance. So we get v new is going to be 2g times 2d. So it looks like that is radical 2 times the v that we started with. So that's another 2 pages done. I believe it's pages 5 and 6. Can't be completely sure.